British Science Week continues, and we've got another great UMPO interview today as Jas talks to someone who uses physics to study everything from biology to politics.
My name is Jasmine. I'm a fourth year physics student at the University of Manchester, and I'm here with Tobias Galla. So would you like to tell us about who you are and what do you do?
Yeah, hi. So I'm Tobias Galla. I'm a professor of theoretical physics at the University of Manchester, and my field of work is statistical mechanics, complex systems and applications in other areas such as biology and the social sciences, for example.
Okay, thank you. So can you open that up a bit more? So what does complex systems mean for someone who might not be familiar with that?
So complex systems are generally systems in which many things interact. And a good example is a traffic jam, for example. So on a road, you have cars that are going ahead, and all of a sudden you get traffic jams. You can make computer models of these, and what you find is that you make relatively simple rules of cars going ahead at a certain speed, and they want to keep a certain distance from the car ahead of them. Then if you add a bit of noise and say sometimes a car goes a bit slower or a bit faster than they want to, you get traffic jams out of nothing. And that is what is called an emergent phenomenon, i.e. It happens because many of these cars are in that system, and you can't understand this if you look at one car alone, because the rules for each car are very simple. And that kind of thing happens in many other systems, in stock markets when you have crashes, and in epidemics when they spread, and in various other contexts. And statistical mechanics provides mathematics to study such systems. And that's what we do.
Okay. So you mentioned epidemics. So would the spread of COVID be kind of where you could apply complex system studies?
That's correct. Yeah. So in fact, many researchers in complex systems or statistical mechanics are sort of spending quite a lot of their time on COVID now, or research related to COVID, and that includes the spread of epidemics, and spreading processes are quite commonly studied in this area. The same is true for how rumors spread and other things, and the mathematics for this frequently comes from complex systems.
Right, that's really interesting. Very topical as well. So what would you say an ordinary day for you is at work, like as a professor? Like what do you do in an everyday life?
Yeah, well, first of all, obviously there is not an ordinary day. It's sort of relatively varied, and so there's fixed things that you have each day. I mean, lectures you give, or tutorials, or PhD students you meet, and things like this. But then there's also time to do, what you feel like doing. So you think about problems and you read things, and that's often very enjoyable. And so it's a combination of research, teaching, and then administration, things like admissions, for example. But it's many things happen each day. So it's,
yeah. Would you say that's kind of what attracted you to go into academia in general? Was it just doing research, or?
Well, that's a good question. Well, I don't know. I mean, you don't know, right? When you're a student or a PhD student, you don't know what life is like as an academic. I mean, when you're a PhD student, you think about one problem or two problems, right? And very hard problems. And then when you become an academic, then, so it's more like my days are often spent, like I look at 100 different things. Each one of them is easy, but they come all together, right? And it's very different, right? And then you're kind of happy when you have time for research where you can actually look at a kind of harder problems, right? But overall, yes, it's the excitement for physics that sort of drove me into this. Yes.
That's great. How about if we go back in time a little bit, like when you were kind of thinking about university and things like that, like what made you think that, oh yeah, I'm going to go and study physics?
Well, that's a good. Well, I must say, I never really thought about it. So because in the following sense that I've always liked maths and physics at school, and I was sort of good at it. And then I thought, well, that's what I want to do. And the only decision was, should it be maths or physics? And nothing else was ever kind of on the table in a way. And then in the end, I ended up in physics. So
okay,
it was pretty clear. I was very lucky that I wanted to. I knew what I wanted to do.
Yeah, I guess a lot of people don't kind of, well, I don't know. I think there are some people who kind of stumble into physics. I know like a lot of my friends on the course are like, yeah, I was really good at maths and physics, so kind of just went into it.
Yeah, it's frequently, and also in my case, motivated by sort of cosmology and particle physics. I think everybody in first year wants to go into these areas, right? And it's very rare that on a UCAS form you read that somebody wants to do statistical physics, right? I've never seen this, or optics or something like that. Yeah. Everybody comes in wanting to do particle physics or cosmology, but then over the course of your degree, you realize that there are many other things that you can do. And ultimately, I opted for this kind of the area I'm in now.
Definitely, yeah. I think I was guilty of that, or not guilty, but I fall into that category as well. I wanted to do astrophysics before I came into first year, and I realized that that's not the type of physics that, like, I think everyone has a very different idea of what physics is like, and then you come into university and you kind of realize it's very different from that.
Yeah, but that's a course like in Manchester gives you that opportunity, right? Because it's so big, the department, you'll see all aspects of physics. Absolutely. And things like where you say, oh, wow, I didn't know that existed, right? And then you can choose. So you can still do astrophysics or cosmology or particle physics, but you can also choose to do something else. So
absolutely, yeah, I think that's really good about our degree. And you get to do like so many experiments as well, which is really, really interesting. So we kind of touched upon this already, but why would you say studying your field of physics is important for the sort of wider community?
Yeah, no, so statistical physics, or the study of complex systems, as we sort of already alluded to, makes contributions to many other fields. So, for example, I work with biologists who look at the evolution of antibiotic resistance, which is obviously a big public health problem, right? That there are strains of bacteria that you cannot treat with existing antibiotics, and you want to understand how this happens. And we have worked with experimentalists who study this in petri dishes in the lab, and one of my PhD students who just finished did models of this, and that maybe helps to optimize treatment options. Another student of mine works on medical statistics, so how to aggregate data from multiple medical trials. If you want to compare different treatment options for a different disease, that's a complicated statistical problem. And we've injected physics ideas into this, and the list goes on. We've mentioned epidemics, we've mentioned traffic jams, and that's why it's important, right? And then you have a pandemic coming, like now, nobody knew about it, and all sorts of different scientists are involved in this, and they all make their contribution in some way. So this notion of science that you have one single individual kind of saving the world, this doesn't exist, right? You need a broad science base of all different fields, and they all contribute in some way.
Absolutely, yeah. So in that way that you have this large group of people contributing in some way, do you work with other sciences, with other kind of disciplines, or is it just physics?
No, so it's so the biology collaborations that I mentioned. Then there's another biology collaboration with people who in developmental biology. So they study how the brain forms fundamentally and how cells make decisions, what kind of cells they want to be. And there's genetic regulation going on and gene circuits that we model. And then, interestingly, we just published a paper with linguists in Manchester, where we studied how languages evolve over time, and how one can, with a model, a physics-inspired model, can infer information about that process from data about how languages or features of languages are spread across the globe. So that was very interesting.
Yeah, very interesting. That I think that's what, because obviously we're kind of aiming these towards secondary school kids, and I think at that level it's really hard to see that how generally applicable physics is in a lot of disciplines. So it's great to hear that from kind of someone who actually does that, as a job.
Yeah, I mean, when I was 18, 19, I had no idea, right? And then it just sort of gradually you learn about these things, and it's a kind of, you can ask, what is it that puts physicists in a position to contribute to these things? And it's mostly sort of the way we think, right? If you finish a physics degree, or you're trained, you know a lot of maths, you know the modeling, you will have done computational modeling, so you have computer skills, but most of all, you have a skill to make abstract models of complex phenomena. You talk to somebody in linguistics or in biology, they tell you about their problem, the thing that they're studying, and you sort of listen to them for a while. And then after 20 minutes, half an hour, you say, well, okay, stop. I don't understand anything. But in your mind, you've already kind of, okay, I want to make a computer model of this, right? And then you ask, okay, that process there that you mentioned, is that faster than this or slower? Is that positively affecting this thing or negatively? Is that thing there really important, or can I leave this out? Or things like this. And then more often than not, they sort of go, wow, these are interesting questions. We've never looked at this in this way. Let's talk some more. And then you make a model, and then they say, well, this is completely crazy what you're doing, that model, because you have to do this, and this. And then it sort of evolves over time. And so it's not your knowledge of Newton's equations that helps you. It's more the way that you think, I think.
Absolutely. Yeah, I definitely agree. I think, so I'm in my 4th year now, and I think kind of every day I'm starting to realize how much sort of problem solving skills I've developed without even, it kind of just happens. You don't really even realize, like, obviously day to day you're kind of studying, you know, optics or, like you said, Newton's equations or something, and then in the background it's like slowly kind of developing this skill to solve problems in a very unique way.
But yeah, you don't, and sort of when you sort of, from my point of view, when you teach a course, I mean, I always say this when I teach a course, right? I say, like, the immediate aim is to prepare the students for the exam over the last time. Yeah. But then there's also a wider aim, is to help students become good physicists. And that is that kind of thinking or problem solving or approaching a problem. And then, I mean, if you give a course on classical mechanics, then classical mechanics is sort of a vehicle in a way to transmit that broader physics thinking, right? And it could have been electrodynamics or any other area of physics. That's really important, I think.
Absolutely. I think that works as a kind of motivation to people who are maybe doing physics or like studying physics in secondary school, and they're like learning the sort of basic skills and the basic equations, and you're starting to learn a bit about mechanics and thermodynamics. And I think for me, when I was studying it, I couldn't kind of see why do I need to know these things? But then kind of, I think now that I'm in university, I know that that's, like you said, it's kind of like the vehicle to bring you to this point where you can apply all of these tools that you've learned to actually look at more difficult problems and more kind of almost interesting problems as well.
Yeah, I think that's right. And it's also you learn how, so different people learn in different ways, right? And when you're a student, you learn how you learn best. So how everybody has their own method of reading lecture notes or adapt or kind of absorbing the material, right? Some people, I don't know, there's different ways of doing it. And I didn't know what worked best for me. And over the years of my degree, I sort of understood what's most efficient for me, right? And yeah, that's another. And another element is actually communication skills. So students don't. So whatever you do later in life, after your degree in physics, you will be better at that, whatever that may be, if you communicate well, if you think clearly, and if you communicate well. And every problem sheet that you do in a physics course, or every essay that you write, or every presentation that you give is preparation for that and helps you to develop these skills. And you don't realize this when you're in your first year and you're kind of asked to go to the whiteboard to present your solutions for some mechanics problem, right? But it is ultimately that. And it's many of those that then help you later to be good at whatever you want to do.
Definitely. Would you say, do you have any advice to students of, any level to kind of further develop that? Because I know, having taken your courses, and like, I know that you particularly are really good at kind of communicating things in a more simple way. So do you have any kind of advice for someone who might be struggling with that?
You mean with communicating with?
Yeah.
Yeah, that's very difficult. I must say, when I was a student, I'm not sure how good I was at that. It comes later in life through other things. The only thing I can say, but it's sort of, once you realize, it's obvious that you have to be aware of this sort of empathy, right? know who you're talking to and what they can possibly know and what they don't know, right? And that's put yourself in the position of the person you're talking to. I mean, it's sort of obvious, but many people, including some colleagues, are not very good at this, right?
Yeah.
And then also a bit of personality, right? That you're not a robot, and it's not all just kind of boring science, right? It's kind of I don't know, that's what I try to do.
Yeah, I think and I think that shows definitely, because I think and I think there's a bit of a stereotype in physics that like we at University of Manchester Physics Outreach UMPO are trying to kind of break as well, as to make children and the wider public realize that it's not just, you know, the same type of people, you know, the like gray-haired old men, you know, writing in front of a blackboard. Like that's not, especially now that physics is all about. So it's good to hear from.
No, and I mean, people don't, I mean, you know, sometimes I meet students in the gym or something, right? And there's a student, oh, wow, Tobias goes to the gym or whatever, right? And they're sort of shocked, but of course we are all just humans, right? And we do exactly what you do, right? We go to the pub, we go to the gym, we do, okay, well, children and family, but like physics is one part of our life, but not the only one, right? So of course we're all just people, right? And I don't mind in lecture sometimes mentioning things from my personal life, right? And so yeah, and this also, that's another aspect that when I was a student, and you thought like, oh, they're the professors, right? They know everything, and then the older you, or the, you know, you go through the degree, and then you actually realize at some point, well, these or, you know, they have more experience, but they're not necessarily, there's no guarantee that, or no reason why I should be smarter than you, right? Mm-hmm. It's just, I have been doing physics for, I don't know, 20, 25 years, and for you, it's been a lot less. And you don't realize that at the beginning, and you think professors have the answers to everything. But once you're a PhD student, you kind of realize, well, no was the answer, right? And towards the end of a PhD, you often know more about the problem than your supervisor will. And in fact, good students, or good MPhil students, come to me and say, well, Tobias, you're wrong and we're right, and here's the evidence. But that realization that it's not just, you know, people who know, you know, the professors know everything, and that's not true, right?
Absolutely, yeah. That was actually one of my questions is, do you know everything about physics? Would you say?
Well, no, of course not, right? I mean, no, of course not. And then there's always new stuff to learn. And it was, you know, yeah, I have this experience, like, I mean, very recently, basically, well, we use a certain algorithm all the time, the Gillespie algorithm. It's not important what it is. Mm-hmm. And recently, a PhD student told me about a variant of that I didn't know about. And I was like, I've been working with this algorithm for 15 years or something. It's like, wow. And I was shocked. How is it possible that I had never heard of this? And then I told other colleagues, and they said, well, this is shocking. I will type up some lecture notes now and put this in my, and it was like this, right? And you learn stuff every day. And that's but it's also being part of being a good scientist is also being aware of that, right? Your limitations. And so what I don't like is when people go out and comment on things that they don't really have very strong views on things, or express very strong views on things that they don't know about. So there's many physicists going out now saying lots of things about epidemics, but they've only started working on epidemics like a year ago. And there's other people who have been epidemiologists like for all their careers, right? So there's no, physicists can contribute, but you can't go there and say, I know everything. I'm a physicist, I know everything. That's very disturbing somehow.
Yeah, definitely. I agree with that. Like, I think even kind of when I was starting my undergraduate degree, I was kind of thinking like, oh yeah, in 4 years' time, I'm going to be Master of Physics. I'll know everything. And it's just not true. And I think it's like the more you kind of learn about things, the more you realize that you will like basically never know everything about anything, which I think can be kind of shocking, but I think it's a good thing to know as well. And kind of like you said, to be aware of the fact that you don't know everything. And I guess that's part of the job as well, to kind of learn more.
That's right, exactly. But it's sort of, I guess, I don't know, when you're at the beginning of your degree or something, at some point or maybe you finish school, you say, whoa, now I know a lot of physics, right? And then towards the end of your degree, you may say, well, maybe I don't know anything. But then in the PhD or maybe then you realize, well, nobody knows anything really, right? It's not just you, but somehow it's still it still works. It's not true that nobody knows anything, but it's nobody knows everything. And then but once you realize what the limitations are, that also determines the confidence that you can use to express, your results. And you also have to, like, right? Everything can in principle turn out to be wrong, right?
Yeah.
But that's just the way it is. And a PhD or a research paper just reflects the knowledge of at the time. And if it was done correctly and appropriately, then these are the results at the time. And if then the results change because new evidence appears, well, then so be it, right?
Yeah, absolutely.
Doesn't mean that you're stupid or that you did anything wrong. It's just a natural.
Yeah, definitely. So I've got one more question.
Sure.
So what advice would you give somebody who's in school, who might be thinking about a career in physics, or somebody who isn't quite sure about what they want to do? Do you have any advice for that?
That's sort of, I'm sort of trying to, that's difficult because I knew what I wanted to do. I guess talk to many different people and sort of different disciplines. I mean, you will have probably an idea of what roughly you want to do, right? And then you start talking to people and go to open days and look at web pages and see what interests you. And often you can do it by elimination, right? And so, well, that not, and that not, and that not, and then see what's left. But often you get a kind of feeling relatively soon if you look at a web page or if you talk to somebody. You say, well, I don't understand what they're saying, but it sounds interesting. And ultimately, it's gut feeling, right? You'll get advice from your teachers, from your parents, and they say, do this, do that. But ultimately, you have to. It's kind of when you found it, you know it in your heart that it's the right thing for you, and then you just do this, whatever it may be, right? And because otherwise, if you're not excited about it, you won't be able to put in the work that's needed.
Definitely.
I'm not sure that helps, but it's very
No, I think that's really good advice, and I think it's just kind of trying out different things as well. Like, I think a lot of people might have the kind of thought that you have to find the one thing immediately, which also I don't think is true. You can do different things, and like you said, in your research, it's not just this one thing that you do. It's so many different things. I mean,
it's physics, or doing a degree in physics to some extent. It requires a level of kind of devotion, and you have to really be excited about it, right? So if your plan from the outset is, I do the degree and then I want to do something else, then I would maybe think about it, right? And then if a physics degree is mostly a strategy to do then something else, then I would maybe sort of think carefully. Although it must be said, a physics degree is a good strategy to go into finance, for example, right? If you want to do that. But there's other ways of doing that. So I don't know. It's like go to open days, listen to people, and then examine. I mean, I don't know, gut feeling, right?
Yeah. Yeah. Okay. I think that's really good advice. Definitely. So thank you so much for taking the time to answer my questions. Is there anything else you want to say?
No, I do physics. It's one of the best decisions I've made in my life. So it's.
Oh, that's great to hear.
Thank you for joining us today and throughout British Science Week. We really hope you've enjoyed the interviews that have been on, and that you will join us for a special bonus episode where we meet Josh Hayes, the astrophysicist who started this off. Don't forget to like and subscribe and spread the word to your friends. The hashtag is DSW21 and our social media accounts are @UMPhysOutreach. Thank you for spending the time with us.